5 years ago, in a conference room in New Orleans, a group of glaciologists did something scientists almost never do. They put a date on a disaster. They were studying the widest glacier on Earth, a slab of ice in West Antarctica the size of Britain, more than 2,000 meters thick in places, responsible all by itself for about 4% of the sea level rise happening across the entire planet right now. And they warned that one part of it, the floating shelf out front, would likely shatter like a cracked windshield within 3 to 5 years. That was 2021. The window they drew closes this year. Now, here is the part that gets misread in almost every headline you are going to see about this. The shelf breaking apart is not the catastrophe. It will not raise the ocean overnight. And anyone telling you the coast's drowned by next month is selling you a cartoon. What that shelf is actually doing out there is far more important than it looks, and losing it does something much quieter and much worse. In the next few minutes, I will show you exactly what that line was, why crossing it matters even though nothing floods tomorrow, and what you should actually be watching for on your own coastline. No guessing, no doom, just the mechanism, the science, and the real stakes. To understand what just happened, you have to go back to that windshield. Dr. Erin Pettit and her colleagues had been watching the Thwaites Eastern Ice Shelf, the floating tongue of ice that juts out from the front of the glacier into the Amundsen Sea. And what they saw in the satellite record was a set of cracks spreading through it the way a chip spreads across a windshield. You know the feeling. You tell yourself you will get it replaced. The crack is small. The glass is holding. Then you hit one bump in the road and the whole thing goes at once, into 100 pieces in a single second. That was the warning, 3 to 5 years. Then, late last year, a team at the University of Manitoba published the follow-up nobody wanted. They had gone back through 20 years of satellite images and GPS data from 2002 to 2022 and measured those cracks directly. The total length of fracturing across that shelf had grown from around 100 miles to more than 200 miles. The shelf was pulling away from the thing holding it in place. And their read on the timeline lands the breakup in 2026, right on the original deadline. Let those numbers sit for a moment. A prediction that specific, made 5 years out, arriving right on schedule. That is not something glaciologists get to say very often, and it is not something you want to hear them say. So what is holding this shelf in place, and why should you care that it is letting go? Here is where it gets interesting. That floating shelf is not just drifting on open water. Out near its far edge, about 50 kilometers offshore, the underside of the ice is snagged on top of an underwater mountain, a ridge on the sea floor. Scientists call it a pinning point. Think of it as a doorstop. The whole floating shelf is leaning against that one bump, and that bump is bracing it, holding it still. And a braced shelf does something you would never guess just by looking at it. It works as a brake. The ice behind it, the enormous grounded ice resting on bedrock, is always trying to flow downhill toward the sea, because that is simply what ice under its own weight does. The shelf, jammed against that seafloor ridge, pushes back up the glacier and slows that flow down. And we can actually measure the effect. The eastern part of Thwaites, the part sitting behind the brace, moves at roughly 1/3 the speed of the section right next to it that has no such brace. That is the doorstop doing its job. But warm ocean water has been getting underneath it. Not a trickle. Researchers with the British Antarctic Survey have tracked seawater pushing more than 6 miles in under the glacier, melting it from below, thinning the ice over that pinning point until its grip starts to loosen. And this is not new either. Sediment cores pulled from the seafloor show Thwaites began this retreat back in the 1940s, most likely set off by a powerful El Niño. It has been accelerating ever since, and it's sped up considerably over the last 40 years. What is arriving now is the moment the brake finally slips off the bump, and that is the reframe that changes the entire story. When you read that the ice shelf is about to break apart, your instinct is to think the shelf is the thing we are losing. It is not. The shelf was never the threat. The shelf was the break. Losing it adds almost no water by itself. Losing it takes the brake off everything parked behind it. Now, if you have been paying attention, you might already be waiting for the obvious objection, so let me get ahead of it. That floating shelf is already sitting in the water, and floating ice does not raise sea level when it melts, the same way an ice cube melting in a full glass does not make the glass overflow. It is already displacing its own weight. That part is completely true. The shelf is a cork bobbing in a bottle, but the cork is not the wine. Behind that floating shelf sits ice that is not floating at all. It is grounded, resting on bedrock, sitting on land, held above the waterline. That ice has never been counted in the ocean's volume, and when the brake comes off and that grounded ice slides faster into the sea, that is new water. That is the part that raises your coastline. So the shelf melting does almost nothing to the sea directly. The shelf breaking up speeds up the delivery of the ice that does everything. And this is where the scale stops feeling abstract. Thwaites, all on its own, if the whole thing eventually goes, holds enough ice to lift global sea level by about 65 centimeters. Call it a little over 2 feet. That is already enough to redraw coastlines. But Thwaites is not standing out there alone. It sits like a cork in the neck of the entire West Antarctic ice sheet, the plug holding back a basin of ice many times its own size. Pull the cork, and scientists cannot rule out that the ice behind it follows. If that larger collapse ever plays out, you are no longer talking about 2 feet. You are talking about something closer to 11. That is the reason this one glacier, out of more than 500 named glaciers in Antarctica, is the one that earned the nickname. And here is the part that sounds almost impossible until you see the shape of the land underneath. The bedrock beneath Thwaites does not slope up as you go inland the way a normal beach does. It slopes down. The ground under the glacier gets deeper the further back you go, into a huge inland basin that sits below sea level. So as the grounding line, the spot where the ice lifts off the bedrock and starts to float, retreats backward, it retreats into deeper and deeper water. Deeper water means thicker ice at the edge, and thicker ice flows out faster, and faster flow pulls the grounding line back further still. It feeds itself. Glaciologists have a name for this: marine ice sheet instability, and it is the reason they keep using a word they hate to use about ice, which is irreversible. On a bed shaped like this one, past a certain point, the retreat stops needing a push. It just keeps going. Which brings us to the 2 stories you are going to hear about all of this, both of which fall apart the second you actually check them. The first is the panic version, the idea that Antarctica is about to let go and drown every coastal city inside a decade. It will not. A study out of Dartmouth ran the collapse through updated, high-resolution models and found that the most extreme runaway scenario, the one where exposed ice cliffs crumble under their own weight in a chain reaction, is unlikely to happen this century. The lead scientist was careful, and he was blunt about it. In his words, "We are not saying the Antarctic is safe." A full Thwaites collapse most likely unfolds over centuries, not seasons. So the doomsday clock is real, but it ticks in decades and centuries, not in next summer's headlines. The second story runs in the opposite direction. You will hear that this has nothing to do with climate change at all, that it is volcanoes, that there is a field of magma under West Antarctica cooking the ice from below, so warming plays no part in it. And here is the honest part. There really are subglacial volcanoes and geothermal heat under that region. That is real science, not a rumor. But that heat has been sitting there for millions of years. It is a slow, steady background, a warm floor the ice has lived on the entire time. It does not switch on in the 1940s. It does not double over 40 years. A constant cannot explain an acceleration. What changed, what actually lines up with the timeline, is the warm ocean water reaching the base of the glacier. Neither the panic version nor the volcano version survives contact with the facts. So who is actually standing in the water when these numbers start to move? This is the part I want you to really hear. Around 230 million people on this planet live on land within 1 meter of the high tide line. Widen that to 10 meters, and you are looking at roughly 1 billion people. That is not a projection about the year 2200. That is where people live right now, today. And you do not need 11 feet to break a city. A single extra foot of sea level turns a storm surge that used to arrive once in a lifetime into one that arrives every few years, and it does it to the same low, flat, crowded coastlines over and over again. Sea level does not rise evenly, and it does not knock politely. It shows up as the flood that used to be rare, quietly becoming the flood that is routine. Let me be direct about what this does and does not mean, because that calibration is the whole point of this video. It does not mean your street floods this year. It does not even mean the glacier is gone this century. The full collapse, if it comes, is a multi-generational event. What crossing this line does mean is that a break, which has been slowing one of the most dangerous ice systems on Earth, is coming off. And once grounded ice in a basin shaped like this one begins its fast retreat, there is no easy way to jam the brake back on. This is less a switch that flips and more a door that only opens one way. So here is what to actually watch for, and it is the part that unsettles me the most. In the coming months, watch whether that eastern shelf breaks up on the timeline the models drew. Then watch the speed of the ice behind it, because the acceleration of the grounded glacier is the number that truly matters. That is the signal that the brake is off for real. And here is the uncomfortable footnote to end on. The International Thwaites Glacier Collaboration, the joint effort of around 100 scientists that gave us nearly everything you just heard, is winding down. Its main research icebreaker, the ship that puts instruments and human eyes directly on this glacier, has been pulled by budget cuts. So we are walking up to the single most important moment in this glacier's modern history with fewer people watching it than we have had in years. The line got crossed, roughly on schedule. The open question now is whether anyone will still be out there to measure what happens on the far side of it. None of this is a reason to panic. It is a reason to pay attention, to know the difference between the real threat and the cartoon version, and to watch the right numbers instead of the loudest ones. If you found this useful, YouTube also thinks you are going to like the video on your screen right now. Go ahead and click it.